D1? Is it not there? Test your understanding, no D1 meh? Oh, okay, okay. Can you drop me a message? Ask me for test your understanding for D1. Yeah, I'll upload it. Okay, yeah, Justin is done. Justin also don't need. Okay, Ken. Yeah, bye. Okay, there's this question I want to go through, but let me just check with Portia and Jovine. Did the school, I heard from the students earlier, did you have this for schoolwork? Like, okay, then I'll go through this one here. All right. So this is another version of one of the questions I did, right? Another version. And basically, like, let me just, oh dear, oh dear, oh dear. Okay, Erica, right? Let me try to do this as fast as I can. Okay. Oh gosh, what's going on? I'm trying to. Okay. No, because I know it's late for you. Okay. So we've got a block of mass 2 kg, right? Placed on a mass trolley of 5 kg. So I'm going to write all this down to make sense. Moving horizontally. So the block is experiencing an 8 Newton force and it slides on the surface of the trolley. Okay? Right? So this is a version of, I think, one of the questions I went through before. So they tell you that the trolley is accelerating at 1 meter per second squared. So, and then there's no frictional force between the trolley and the ground. So like, this thing here like is frictionless. So the question is, why is the trolley even accelerating? Like, look at the trolley. So this is a May 23 paper. Right? Why would the trolley accelerate? Okay? So we have to focus on the trolley first. We have to ask ourselves, what's making the trolley accelerate? Like, let's understand that the 2 kg mass is not like stuck to the 5 kg mass. It's actually sliding over. So let's look at this guy and try to figure out what force could have caused the trolley to accelerate. Okay? And the only thing, after a while, after you've done all the practices, after you've seen some of my lessons, you realize that, oh, the only possible force that's acting on the trolley would have been a frictional force where the 2 kg mass is dragging the trolley along. So this frictional force here, I'm trying to draw it here like that. Okay? Okay, so at some point, right, some students will be very, very perturbed by this. But the question never said there was friction. How can we infer there was friction? Right? That's the thing. You're supposed to. That's the 1 mark. Right? The 1 mark comes along with you inferring that for the trolley to accelerate forwards, there must have been a force acting on it. And the only thing that's kind of like touching it and giving a force is a 2 kg mass. And as you drag the 2 kg mass along, the 2 kg mass like scrapes the top of the 5 kg mass, and therefore it manages to move the 5 kg trolley along as well, right? So it must be friction, and this is the resultant force of the trolley. So friction is equals to ma, right, for the 5 kg mass. Like, the friction acts on the 5 kg mass, the 5 kg mass accelerates at 1 meter per second squared, so the friction F equals to ma is for the 5 kg mass, 5 times 1, right? Which tells us that the frictional force is 5 newtons, right? Frictional force is 5 newtons. Okay. So now they're asking you, what's the coefficient of dynamic friction between the block and the trolley? Damn. Right? Okay. They're asking for the coefficient of dynamic friction between the block and the trolley. So they're asking you, right? What is the mu d for the surface in between? Right? What's the mu d here? Like, how much mu d, right, dynamic, right, friction is there, right? That's your job. Okay. Well, quite simply, if it's 5 newtons, okay, then we know that friction is mu d n, right? Mu d times n. But whose n, right? The 2 kg masses n, right? This n here. Okay. right? So 5 is equals to 2 mu d n, right? I don't know what the options are. The options looks a bit, don't know whether, I mean, but there's no calculator here at this point in time, right? For all the past year papers, MCQ, no calculators, but if you had a calculator, then you probably will have to write, okay? 5 equals to mu d, right, times the weight of the 2 kg mass, which means 2 times 9.8, okay? 2 times 9.8, right? The normal contact force is the weight of the 2 kg mass, right? Which works out to be what? Mu d equals to 0.25. Yeah, MCQ you can use calculators. If your teacher tells you MCQ cannot use calculator, you show them the syllabus and remind them that it's 2025. What? Oh, the G can be 10, then it'll be 5 divided by 20 lah, right? But in this case, if your options, I can't see my own options. I'm blocking it myself. I'm so sorry. I couldn't find a part where 0.255. Yeah. Okay. I mean, I could ask other questions like, what is the acceleration of the 2 kg mass, right? And then we have to infer that, oh, if you want me to find the acceleration of the 2 kg mass, then I have to understand that the friction acts backwards on the 2 kg mass, which is 5 newtons. The pulling force is 8 newtons, right? The resultant force therefore is 3 newtons, and the acceleration would therefore be 3 divided by 2, 1.5 meters per second squared. Okay? That will be the acceleration of the 2 kg mass. Then I've had a question from the previous batches before. They asked me, oh, so does it mean that if I were to do this, eventually the 2 kg mass will slide off the trolley because the acceleration is 1.5 and the bottom acceleration is only 1? Yes, right? But we are not too concerned about that. We're just concerned about the now, right? I just want the values now. They want the values now. What happens after? If they ask, they ask. If they don't ask, they don't ask. They just want the now. Yeah. Yeah, just to trick you. Yes, Eric, yeah, you're right. The 8 Newton force is useless. Right? Telling us about the 8 Newton force has no value. Yeah. Yeah, this question like May 2023. So the May papers always gives me surprises every year, right? I'm just waiting for next Tuesday. Next Tuesday, the May paper. Okay, let's start with the one of the questions that was asked. Sorry, what was the question that was asked? Oh, yeah, this one here. Sorry. Uh-oh. Okay, this one here. Wow, this one Asana. Yeah. Look at May 23, man. May 23 is scary as hell. Okay, ball 1 is released from rest at the top of the building. At the same time, ball 2 is projected horizontally from the same height. Effect of air resistance is negligible. Okay, so you would have, like, because of my lessons, you would have remembered that. You can ask, so what happens if, for those who don't know this, right? Then too bad for them. Okay, you would have from my lessons remembered that these two balls will hit the ground at the same time. Pump, right? Because their vertical displacement is the same, their vertical acceleration is the same, so they will take the same time to cover the same vertical distance. Okay, right? So I'm anticipating maybe an option will be something like which of the statement is true, right? Or they will hit the ground at the same time, right? Maybe that will be the case, right? Hopefully. Okay, but do take note that if ball 1 reaches the bottom with a certain, let's say for example Vy, for example, then ball 2, upon reaching the bottom here, right, ball 2 reaching the bottom here, he will have the same Vy, but ball 2 has a forward component, right? Because it always had a forward component. So it always had a Vx, right? And the Vx has always been constant Vx, like this Vx, okay? So in terms of like speed or velocity, I would expect the both of them to have different final velocity, right? Because the projectile motion has a forward velocity. But the time taken to hit the ground would be the same because that would be dependent on the vertical component, Okay, so let's see. Let's see. These answer. All right. Velocity or impact with the ground is the same for both balls. That's wrong because I just said that it's different velocity. Time taken to hit the ground is greater for ball 2. Nope, it's the same time. I just said that. Speed of impact with the ground is the same for both balls. Is A, if A is wrong, then B, then C is wrong as well, right? So the velocity of impact and the speed of impact is just right the magnitude of it, right? The magnitude of it. Yeah. Oh yeah. In fact, A is wrong because the magnitude is different. The direction is also different because if you tell me velocity, right, I have to take both magnitude and direction, right? So ball 2 is like this. Okay. Any clarification for this? You want me to emphasize anything here, Portia? Sorry, this is okay, huh? Okay, can, no problem. Right? Don't worry about it. It's cause like I'm more concerned about those who didn't ask any questions. Right, let's look at the next one. Oh, the next one is not easy, man. The next one I've seen this one before. Yeah, next one's hard. Um yeah, this one here. November 2022. Okay. You know what's the at the end of the day, right? You know what's the IB trick? IB knows that you all will find some way to sacrifice some chapter. IB knows that for the old syllabus, right, there was this chapter called Topic 7. It's called Particle Physics, where students had to learn subatomic particles. That means particles that are smaller than protons and neutrons, called quarks and leptons. Wow, everybody hated that chapter, right? Because there's so many things to go and memorize and understand. No, everyone just treated it as a sacrifice chapter. Jokes on them, because IB what they do is this: they make the kinematics or the dynamics questions harder, then they make the questions for the complex chapters easier. So you try to play the game, right? You try to play like you want to play some game where you can sacrifice the chapters and all that. You like it doesn't work for IB, man. Yeah. Okay, let's see this. Lightning. See, see. Do you need me to unplug it? Yo, you need to use it there, is it? Hang on, let me just unplug it first. Here. Okay, you plug it next to the projector. Don't turn off the projector though. Watch out for the switch. Okay, guys, this this picture here, right? I mean, I'm looking at it. I got worried, and then when I look at it 2 times and I look at it 3 times, then I realize, it says it's launched vertically upwards. So why does it look like that? Okay, so the thing is this is a graph. It's just a graph. It's just showing the graph of the height versus the time. We are not launching two balls, one at an angle like that and another one launching like that. We are not launching two balls like this and trying to find out what's the cross. No, we are not. You know what we're doing? We're actually dropping one and shooting one vertically upwards. So ball one, being the red ball, is being dropped from a certain height h, and ball 2 is being shot upwards at a initial speed, right? At the initial speed u, and at time t, at certain time t, right? They have the same distance above the ground. So in a way, at a certain time t, right? At a certain time t, they meet each other here, right? So kind of like the two balls meet each other here like that. Okay. Uh, I don't know, man. It feels like I've had, you know, what am I supposed to do? That means, oh boy, wow, this is hard, man. My brain is cycling through this. My brain is cycling through this. Oh, 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 oh. Yeah, this is kinematics. This is kinematics. Okay, so to be very fair, this is a wrong question number. I think this one is like the whoever prepared this document wrote that question number 21. So sometimes I use the question number as a clue, right? It's likely to be purely kinematics. Okay, so how, man? I'm thinking of kinematics. I'm thinking of kinematics. I'm thinking of kinematics. I'm thinking of, yeah. I mean, it feels like you give me time. You ask me for distance, right? It's just one is dropping, one is going up. I'm just guessing this got to do with this has got to do with kinematics because it's time, right? It can't be energy. It cannot be A3, right? It cannot be like KE or GPE because energy has no time factor, so it's got to be kinematics. So I'm locking into kinematics. I'm just, it has to be kinematics. I'm just gonna say that in this time, ball one will have a negative displacement S. Negative? Negative. You see, right? I have to choose one direction to be positive. Because one is going up, the other one is going down, right? I better choose one to be positive. So let's take upwards as positive, downwards as negative, right? So upwards is up is negative, right? And down is positive, right? Down is positive. So I have no choice. And then in the same time, in the same amount of time, this is not like the highest point of this second ball. The ball actually went up a little bit and then dropped down. On its way down, the top ball meets it, right? So no matter what the displacement, let's go with displacement. I'm really committed to kinematics already. I really have no idea. I would just say that this is H minus S. Am I right? Yeah, H minus S. Is the notation correct though? This is minus S, the other one is H minus S. I don't know, man. Okay, let's try this. I mean, I'm just gonna have to try it. So for the first ball, negative S, yeah, right? Negative S, right? Negative S equals to 0 plus half negative G T squared. Okay? I write down for the first equation first. This is hard. I'm not denying that this is hard. Your strategy will be to realize that, gosh, right? Somewhere around here, you stop and move to the next question. No, really, I'm just showing you how to solve this, like, based on like my years of experience, right? I don't think I expect you to know how to do this within the 1.5 minutes allocated. You may come back to this at the end of it. You got to learn your strategy. Don't get stuck on one question and then not know how to do it for the rest of it, right? H minus S. H minus S is positive, right? Yeah, H minus S will be a positive value. Is equals to UT plus half negative GT squared. I think that this should be the case. Yeah. So unfortunately you have to make T the subject. You have to make T the subject. But hang on, very convenient, huh? Hey, look at this. Guys, don't you realize there's one thing that is very convenient? Equation 1, equation 2. I can just get rid of the back term. I can just get rid of it. I can just take 2 minus 1. Right? Pew! It goes away. And then I will have H minus S. Oh, this will be the tricky bit. H minus S minus negative S. I don't know whether this is correct. I hope this is correct. Equals to UT. Yeah, that's all that. I mean, I better hope that this is correct now. I don't know, man. Then H minus S plus S. Oh, becomes H divided by U equals to T. I'm sorry, I would have to just choose C and then quickly move on already. Cause I spent a lot of time on this. Yeah. Is the answer C though? Huh? Okay. Okay. How do, Thanks, Jovin. How did you get the mark scheme? Oh, oh, yeah. Bro, okay, sorry, I didn't scroll down long enough. Sorry about that. Yeah, yeah. Okay, yeah, that's it, right? Now, the next thing is some students at this point will try to think that, oh, this is a relationship that I need to remember. No, not at all. No way. There is no way for you to know that it was what something so random like h divided by speed of launch upwards is the time where the both objects meet. No, there's no, like, I had to work it out. Like, there's no way that I'm gonna tell you something like, yeah, you know lah, when this thing drop and then the thing shoot up, then the time that they meet is when the h divided by the u lor. So easy. Like, no way, dude. Like, there's no way. Like, distance divided by speed equals time. What's that? Like, there's no way to draw this kind of relationship. It's merely just working it out and coincidentally getting this h over u equals to t, right? That's it. There's no way to draw any relationships from this. Okay, right? So the moral story is, when you get this kind of question, you just have to churn it out as quickly as you can and as accurately as you can, right? So this is skill, right? I mean, I'll just tell you I have the skill, right? Right. I know that the ball drop is negative, the acceleration is negative, right? The displacement for the ball going up is positive, the initial u is positive, the acceleration is negative. So this is skill, right? Yeah. Oh, okay, okay. Yeah lah. There's no way to draw any kind of like relationship from this. This is just a one-off thing. Okay. Next question. Hang on, let me just do the next question here. Alright, what's this? Ball thrown upwards at time t equals to 0. Graph shows the variation of time t with the height of the ball. Ball returns, or what's the height of time t? Okay. Alright. So if you've done, I don't care what the options are, right? Like, to me, sometimes the options like look a bit too complicated to me, right? Alright. So this looks like your vanilla projectile motion. You launch a ball. It's not even, this is not even projectile motion. I keep thinking it's projectile motion. It's not. This thing is just being thrown upwards, right? It's just that the graph, when you draw height versus t, the graph naturally stretches out into a projectile motion look-alike thing, right? So the ball is actually just going like the ball is just being shot upwards like that, whoop, up, and then comes back down. Then the question is, what's the time when it's at this height? When this particular height here like this, right? What's the time then, right? So there's just no forward velocity for this. There's only an upward velocity, right? But the shape is still parabolic. It's still a parabolic shape, even though it's not a projectile motion, right? The graph is still parabolic. Okay, and there's only one direction motion to care about, vertical, right? So we have to look at this graph, and then we have to recognize that, based on all the, I think the past examples I've done so far, this graph is s equals to ut plus half. Okay, so it goes up and comes back down, If you take u to be positive, that means when you shoot it upwards is positive, then it's going to be half negative gt squared. Yeah, I'm going to have to put a negative sign there for that one. I don't know whether it's important. I mean, we'll deal with it later. So if you remember what I said about this equation, what did I mention about this equation? I said it was what? Yeah, it's a quadratic function, right? It's a quadratic function. I mean, it's what's the formula? Y equals to bx plus ax squared, right? In a way, so if you sub in y equals to h, you're finding the roots of this graph. You're finding the 2 times, right? The 2 times that it was at time t, right? Or this h, right? The 2 times that it was at h. Sure, by all means. Okay, you know what I'm gonna do? I'm just gonna sub in the value first. Like, let's worry about the rest later. Right? H equals to ut minus half gt squared. Okay? Right? Yeah. You know, and then I'll probably think like, okay, if I can make t the subject, I would have an answer because they want, oh no, yeah. So no, that is just this, right? H, they want me to find H, right? So H equals to ut plus half gt squared, right? Okay. So I try to see, is there an option? Don't have. Why don't have? How come don't have? Like what's wrong? I really put H already, what? Ut minus half gt squared. Why? What's going on? Why is there no option for me to do a thing? Right? I double check. Hey, it's correct what? So why? Why is there no option? So if you look at the options, you realize that there's no U. If you want to do that, can. It's just you have to be very careful how you proceed. Right? I don't exactly know. You can do that, but I generally do not like to split the parabolic motions, if you remember, right? Yeah. You can do that. I mean, by all means, right? But I'm just gonna tell you this, okay? So the reason why this doesn't appear in one of the options, right? It's quite obvious that they somehow want big T in it. Okay? Alright. Now, how about A? Why is A not the answer? I got half GT squared, right? Why can't I just, this is like the closest. Let me just choose A because it's the closest. Right? It'll be completely wrong because you gotta have the UT. What is U? What does U represent? Initial what? Initial velocity, right? It represents initial velocity. Can I just assume that it's zero? Why not? Because it was literally thrown upwards. That means your initial speed cannot be zero. You cannot just like suka just like I think this is the closest. Let me just choose A and then hope for the best. The hoping for the best doesn't happen in physics, right? So UT cannot be zero because you're throwing something upwards. So there's ain't no way that this gonna give you A. Right? So in fact A is gonna be out already. Right? Yeah. A should be out already. Okay, so that means I have to do something with big T. Wow, come on, man. What can we do with big T? What's up with big T? There must be some relationship between this and big T. So if you remember one of the kinematics lesson, and I remember this myself because here's the thing, right? I was teaching you all how to find the total time for your level ground projectile motion, which I know this is not projectile motion, okay, but it's just going up and down. Like how do I find the total time, right? Remember I said that at time t, where's the object again? You threw it upwards with you. At time t, where is it? It's back at the same point again. What's the overall displacement? Zero. So are you telling me at time capital T, the displacement, the height is back to zero? Then I'll sub it in. 0 equals to ut minus half, sorry, this t has to be capital T because like at that specific big T, minus half g big T squared. Now I'm getting somewhere because there is something that can be done here. I don't know what. What can we do here? Well, I have to get rid of the U, right? Like I legit have to get rid of the U. They want me to find H. Like no matter what, I have to find H, right? I have to find H. So you know what? I gotta make U the subject, which is half GT. Right? Yeah? Yeah? Half GT, sub it in, right? And then do the thing H equals to half G big T small t minus half G small t squared. It looks very close to one of them now. I don't know which one. Looks like D's answer. I'll just put D as answer. Yeah. There we go. Yeah, D's answer. Again, please don't try to memorize this relationship, right? I've had students who are like, okay, I'll try to memorize this. Like, every time it's this question, I'll just remember that the answer is like that. No, right? That's not that you're gonna get a mental breakdown soon. Right? So you would have to try to do this method. Okay? Yeah. No. Dude, this is like I've not seen this. I mean, they may repeat the scenario, but the options are different. Like they that's one thing about IB. And especially I tell you already, kinematics they like to make it hard. Right? Because they know that students will try to play the game. Right? They'll think that okay, I just need to ace my kinematics. Then they get this kind of question and be like, shit. Yeah. So your strategy is to be able to do this as fast as you can, right? And try to pick up all the clues that they are giving us. But even then also that stupid 8 newtons also. What clue, right? They give extra clue for nothing. Okay, let's do the next one. Oh, this one, this bird. So annoying, the bird. Yeah. This bird came out in the specimen paper. This bird. This bird. This is hard as nails, man. This one is hard. I remember trying to do this for the previous batch and I'm like, what? Yeah. Okay. So, first things first, we got to recognize that this string cannot be horizontal. Right? It can never be perfectly horizontal. So it's got to have some angle, some way. Right? So which means that we are looking at a situation that looks like this. Wait, let me just draw the line here like that. And let me draw the line here like this. Okay? And then there's the weight here like this. Okay? So even though the bird is heavy lah, right? So the line is sagging a bit, right? I know how he feels. Okay? The thing is this, you gotta be able to draw the forces correctly, so you gotta match up all the forces correctly. So you have this is correct. One string, one tension, that's correct. So the T here, and the T here, right, is pointing this way and this way. Right? It's pointing both ways actually, because he's sitting in. Right, and then there's a MG here. There's an MG here, like that. Okay. Right. So what they're trying, okay, they didn't use MG, they used W. Okay, I put W. This is the weight. Okay. So what they're trying to say, they want to compare is the tension compared to the weight. Right? They want you to compare the tension to the weight. So the breaking out, rather not the breaking point, I mean the bottleneck, right? The most important part of this question, like the crux of this question, is to be able to draw these forces correctly. Okay? Yeah, right. The forces, draw this, and understand that yes, even though it's one string, one tension, there's actually two tensions, one pointing this way, one pointing this way, supporting the bird. But then again, I'll like to tell you that this is again one of a little bit more difficult than normal questions, right? This happened twice in the IB past year papers. Once in the specimen paper. This is a specimen paper. The other one was full circle. The other one was a 2016 specimen paper. The start of the old syllabus at that time, 2016, 9 years ago. Anyway, all right. Different question also. All right. Same diagram, but question was different. Yeah. The other one was asking why is whether the string can be horizontal. This one is asking what is a tension. This is even higher level than 9 years ago. Yeah. So anyway, my long story short, okay, right, blah 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 blah. Understand that the tension needs to be resolved in two vectors. Okay, so there's a theta there, right? Um, rope is almost horizontal, so I must say that this theta is very small. You know what? Let's give it an angle 2 degrees. Right? Let's say it's 2 degrees. Anything from 2 to 10 to 20, that's fine. I'm just choosing 2 for fun. All right? And then the tension is here. Now, don't forget, you guys can use calculator. Right? So this specimen paper, right? This is a specimen paper. It already was catered for using calculators. So if you have to break out the calculator and try to do some numbers, go ahead. Okay. Does this make sense? This tension, I resolve it two ways, horizontal, vertical. This tension, I resolve it two ways, horizontal, vertical, vertical, horizontal. Right? Do we have an understanding that the horizontals balance each other off? Right? And therefore, these two blue arrows pointing vertically must balance the weight. Right? So these two must balance the weight. So am I right to say that T sine theta, right? Two of it, two times of the T sine theta must balance the W. Am I right? Okay, so 2 T sine theta equals to W. Let's just assume theta is small, right? It says do a sine 2 degrees, right? Can you just compare T for me? Yeah, so no. W over 2 times W over 2. Wait. W over 2 times. Sorry, my pen got lost control. W over 2. No. 2 sine theta. Right? 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 No, so what does this turn out to be? Like can you work out 1 divided by 2 sine theta? Like just punch it. Okay, never mind. I have it with me. Right, 1 divided by 2 sine 2 degrees, right? 2 sine 2 degrees, just for fun, right? 14 14 times the weight, right? So D should be the answer. Yeah. Okay. All right. If you were from the previous batch of students and you ask me, how am I supposed to do this question? Then my answer to you is, this question will never come out for the previous batch. Why? Because this would require them to go and estimate what is a sine theta small angle. But that also means that because your syllabus, your batch has access to calculators for MCQ, you were then expected to do some assumptions and find out the numbers by calculating. So this one here, it is bigger than W. Right? Huh? W? No. Yeah. Yeah, we don't know what the W is. You want to assume the W also can. Yeah. Hmm. Yeah. So the 14 comes from me doing the W divided by 2 sine theta. That's why it ends up being 14. Yeah. Wait I need to. Oh, sorry. Oh, shoots. Okay, let's do this one here first. Resistive force is. Hey, this. I don't understand what's going on. I'll be honest with you guys. So this one says November 23. November 23 SL1 paper 1A time zone 1. I don't understand what this means. If anybody can find out from me, like I'll be forever grateful. But I know in November 23 it was still the old syllabus. right? So why is a SL doing this drag question, and on top of that, they never existed a paper 1A also in November 23. So I have no idea how this is a past year paper. This never happened before in the previous syllabus. Okay? Yeah, I know. So I also seen this before. I know where he got it from. He got it from the question bank, right? Which I also have access to. But I just don't know what IB is doing, like labeling it like that. I have no idea where they got it from. It's so weird. No, it's just time zone one. I don't know what's the point one. I don't understand what the point one means. Time zone one means, yeah, but November always only had one time zone. Yeah. This is this is yeah, this is this right. There's the drag force from the equation from the data booklet. I don't know what the data booklet is. The data booklet is the equation correct? Let me see. Drag force is 6 pi viscosity RV. So the thing is that this is viscosity. This n here is viscosity. Right, the n here is viscosity, which is that thing there, right? The cursive n. I don't know whether I got it right, but never mind. And then they say, what's the unit of K? Yeah, this one here. Okay. So this is TOK. This is a bit of TOK. Presence in the form of absence. They basically want you to find the units of K, right? They want to find the units of K, which makes you feel like you need to find the units of this. Like you need to find the units of this. Okay? But maybe some of you never memorize the units of viscosity, but the viscosity unit is Pascal seconds, right? So if anything, units of this, right? This was a Pascal second, PAS. Oh, but I didn't memorize it. And then units of R is in meter. Okay? Right. So let's say you didn't memorize it, and in fact, even if you memorize it as Pascal seconds, right, you might not know even like why is Pascal not even there, right? Then you have to go back and figure out that Pascal is force over area. Then force is Newtons. Newtons is maybe there. Okay? Maybe there. So presence in the form of absence, what you can do is this. You can take the drag force divided by the speed, right? Because V is speed, right? And then this is equal to 6 pi viscosity R. And understand that if you're trying to look for the units of this, it's exactly the units of this. The same units as this one, right? So without knowing what the units is for this, you can find out force over velocity, which means it's newtons, right? Then meters per second minus 1, like that. Okay? And then we see whether there's an option don't have. Right? Oh shit. Right? Yes, you're right, Eric. Okay? Right? So don't have an option here like this. Okay, how? Okay? Then you have to do, you basically have to expand Newton. So this one at least you must know. So we know that F equals to MA. So newtons, the units of newtons, is equals to kg ms minus 2, right? So we need to know the units of this, and then we plug it in. So kg ms minus 2 over ms minus 1, right? And then we simplify it. What do we get? Minus 2 minus 1, that makes it minus 1. M cancels off. Kg s minus 1. D is your answer. Right? Kg s minus 1. So two ways about it. Either you memorize the units of viscosity, which is Pascal seconds, and even though Pascals is force over area, and even then it's Newton per meter, right, times seconds, and you still have to break down Newton still. So no matter what, you have to know that, Newton breaks down to kg ms minus 2. So it's a thing, especially for teachers who are trained in the A levels, right? It's a thing. They like to ask students to express some things in terms of base units. Were you here when I started the very first lesson? In the year, not here, right? Okay. So in the first chapter, no, in topic 0, I mentioned there are base units you need to memorize. Have you memorized the base units? Okay. So if you're not tested on topic 0, maybe not so bad, don't worry. But then at the end of this year, you must memorize it. Okay. So you need to memorize your base units. So sometimes I can ask you things like, I can ask you things like, watts. Give me the base unit of watts. Watts. You see, the problem is watts is a derived unit, right? So if you have to convert this to base units, right? You see, this question is about base units. This question is actually not about, like, the A1 or A2. Watts is what? Joules per second, which is what? Work done over time, right? So work done over time. And what's work done? Force times distance. Force times distance over time. Then you have to break down force into mass times acceleration times distance over time. Yeah, man. Okay? And then you break it down to, then the units will be kg, ms minus 2, m over s. Right? That will be the base units for watts. Yeah, it's a thing. It's a thing. Especially if your teachers are A-level trained, right? The A-levels love to ask this stupid question. But this is not immune enough to IB. IB has asked base units before. Okay, this one. What's the initial acceleration of the pendulum? Initial acceleration of the pendulum. Oh, very, very close. Very close. Very close. This is correct. Right? This is correct. Look at it. This is correct. Very, very close really. This is correct. T cosine theta, mg, t sine theta, right? T cosine theta should balance mg. T sine theta is your resultant force. Right? Almost there, almost there. Just missing one more step. So T sine theta equals to MA. Oh, the font is bad. Hang on. Let me just change the color. Okay. T sine theta equals to MA. Well, technically A is equals to T sine theta over M, right? Because that's the resultant force, right? Right? You pull it and then you let go. There's only two forces, so the forces drawn are correct, T and mg. Okay, so the resultant force is T sine theta. That's for sure because theta is given up there. But then of course, then you'll be looking at this and say, not any of the options there. Don't get stuck. Continue. It's got to be something to do with the other one. There must be something to do with the T cosine theta. I'm willing to believe that it's something about T cosine theta equals to mg. I don't know, man. What do I have to do? I made T is a subject. So T equals what? Mg over cosine theta, is it? Hannah? Do I sub it in? You don't think so? But I should get tangent though. You resolved Mg. You resolved Mg. No. Yeah. No. Oh wow. When the hell did this question come out from, man? Yeah, you're right, Jovine. Yeah, you're right. I'm now trying to figure out. Oh no. Wait. If I were to do this, what does this become? A equals to what? G tangent theta, right? Okay. Okay. Hang on, All right. I shall declare that I made a mistake. All right, that's actually not the correct way of doing it. Jovine mentioned something and I realized that she's right. Okay, okay, I shall declare that I made a mistake. Okay, because you know why? Later on in C1 SHM, when you do pendulum simple harmonic motion, you're supposed to approximate that T sine theta is your resultant force. And therefore, you should be able to find the acceleration from the T sine theta, which is what I did as well, right? You know? But the problem is, in order for you to approximate SHM, the theta must be small. The problem in this question here is that this particular question, this is really a bit high level. So just bear with me. The problem here is that the theta is not declared to be small, so I should not have continued with this. Okay? But I went to continue with it, and I ended up with this answer. A equals to G tangent theta. If you see sine theta divided by cosine theta, it is G tangent theta. Correct? Okay? No. Okay. Hang on. So the thing is, if I set in for the exam for this one, and I would have done that too. I will tell you this, right? I'll declare to you I've done that too, right? I would have just realized that, oh shoots, G tangent theta, right? How? Which one would I choose, right? Okay. Have you done small angle approximation in Sec 4? Never, right? Okay. You will do that next year in year 6 for math, right? You will learn this thing called small angle approximation, right? So if you can remember what I said that, today, 21st April, right? Maybe you remember 1 year later, right? That I mentioned this before. In your math syllabus later on, you will learn that tangent theta, when the angle is small enough and in radians, it will approximate to sine theta. Yeah, tangent theta will approximate to sine theta. So I would have just gone ahead to put G sine theta as answer. Yeah. Okay? Simply because I know that it approximates. However, that's not the right way of doing things. So let's talk about the right way of doing things. So I'm going to have to erase all this, right? And then draw the correct way of doing things. Okay? Now, based on Jovine's suggestion, yes. Okay? So when the angle, obviously the angle is not very small, I should not have taken T sine theta as the resultant force. Because firstly, this is not circular motion. This is not like it's going around a circle. So I also thought that it was T sine theta, but it's not T sine theta. Okay? So we need to recognize that there's a tension here and then there's a mg here. And we need to find the resultant force. So in a way, the resultant force should be T and mg, which should be a bit bigger, and the resultant force should actually be pointing downwards like this. So, in fact, I would expect the resultant force to be pointing somewhat downwards, because when you raise a pendulum to the side, it's going to accelerate down, right? It's going to accelerate at an angle downwards. Again, this is not like circular motion. Remember, circular motion was like that, right? Okay? If it's circular motion, then the resultant force needs to be pointing where? It needs to be pointing right towards the center. But this is not circular motion, so we can't take T sine theta, right? That's a bit unfortunate. Okay? Therefore, wow. Okay, like what Jovine was suggesting, I'm just thinking of another way to doing this, but I don't think there's another way to doing this, right? She's right. We have to resolve it like that. We have to resolve it such that we get a component this way and a component this way. Yeah, that's ugly, man. Yeah. Okay. So the idea here is that I need a component of the mg to balance the t. Right? So I need to have this component here. This is theta. This is the one question I would not expect most people to get it right anyway. Unless they become like me at that tangent theta approximate to the sine theta. Yeah, this is mg cosine theta. And therefore this component here is mg sine theta. Right? So our understanding is since they are in the same line, and this pendulum doesn't break off the string and fall this way or go up this way, it's going to go another way, mg sine theta is the resultant force. So mg sine theta equals to MA, M cancels off, A equals to G sine theta, right? That's the answer. Not easy. I would have made a mistake. If not for the fact that I did the approximation, you know, I would have not gotten the concept right. Okay? Yeah, Jovin, thanks for this. Yeah, you're right. Yeah, we would have to resolve it to the string. So I'm resolving the weight to the string. Okay? Yeah, take down this one. I need to wrap up soon because this guy is really tired already. He's been here since 5 p.m. He's been here for 4.5 hours already. Yeah. No, man. Okay, hang on. Let me just. I think there's a last two here. There's last two. Yeah, the last two questions. Hang on. Yeah, copy down, copy down. Can? Done? Done, huh? Okay, done. I erase this. I paste this over. I need to rotate this again. Okay, there we go. This one here first. Okay. Okay. X moving along with speed v collides with an identical ball initially at rest. Collision is perfectly elastic. Perfectly elastic. This is the key phrase, perfectly elastic, right? We should underline that phrase there. What's the correct speed for X and for Y after the collision? Okay, this one here is a classical, this thing here is classic, okay? If you have the exact same mass, you know, like the Newton, you know what's a Newton's cradle? Newton's cradle, the toy tack on the, yeah, you know what I'm saying, right? Wait, let me show it to you, a Newton's cradle. So there's this thing here, Newton's cradle, yeah, right, which is yeah, this one here, this thing here, right? So the whole idea is that the ball, all them same masses. So this ball will come towards and then hit this one, transfer. What happens to this ball when it hits this one? It doesn't actually bounce back, right? It stops dead, right? Like it stops down here because it transfers all of its momentum to the last ball, then the last ball swings upwards. Like that, right? Yeah, that's what's happening here. Right? That's what's happening in this particular question. Right? So it's a classic thing. Of course, I don't expect you to memorize this. We can work this out, but the answer should be A. Because it's an identical ball, initially at rest, speed V, whatever momentum he has, he transfers over to Y. Okay? Okay. So the key thing is, yes, the RSA is equals to RSS, right? That's great. Okay. The relative speed of approach is V minus 0. So the relative speed of separation should be V minus 0, which in the case B, C, and D doesn't show. Right? Look at this. What's the relative speed of these two? Yeah, they're moving off together. So this is a completely inelastic collision. B is a completely inelastic collision. So B is out. V over 2. So you know, if your speed approach is V, your speed separation should be also V. This is V over 2 versus 0. So C cannot be. Right? And this one here, what's the relative speed of separation for the last one? Relative speed of separation for the last one? No, this is 2V. The RSS is 2V. Right? One object moving backwards V, this object moving forwards V, they are separating at a relative rate of 2V. So in a way, D is also wrong. Just simply by the RSA equals RSS, right? We can more or less tell that only A is a possible answer, right? But we should be able to work it out. So no, this equation looks okay. So firstly, this equation looks wrong, right? This equation looks wrong. And secondly, I did ever mention before, do not ever use the KE equation, right? I think inside one of my, I think the March holidays, right? I went on leave and I asked you all to watch that video. I think in that one video I said, don't try to use this equation because this equation here will mess up all the calculations, right? There's too many squares around already. So this the equation is wrong as well. So what should have been the correct equation? You should have done mx v plus 0 equals to mx. I don't like v, you know. Why can't they just use u? Okay, so mx vx plus my vy. Not knowing what is vx, you know. Like I literally don't know what's vx. But I do know that v minus 0 is equals to vy minus vx, like this, right? I do know that. Okay, right? So these are the two equations, right? These are the two equations. I mean, okay lah. I think maybe, yeah, maybe. No, sorry. This one's right. I'm so sorry about it. The mv1, right, is correct. The mv2 is correct. The m3, yeah, because it's the same m, right? Right. Yeah. Actually, the m is the same, right? M is the same. M is the same. In fact, if m is the same, then I can cancel all, right? Just, yeah, I can cancel out the m. Cancel out the m like this. So v is equals to vx plus vy. V is also equals to vy minus vx. That means the only solution is vx is 0. Right? Vx must be 0 in order for both equations to be true. Right? V is equals to vx plus vy. V is equals to vx minus vy minus vx. No, this first equation, this is momentum, Pocomo. Remember this Pocomo? The second equation here, this is RSA, RSS equation. This is the relative speed of separation, right? So the thing is, right, I mentioned in the I mean, this part here, the first one is correct, but this one here, right? No way, absolutely not, right? In the video I sent in the March holidays, right? I clearly stated do not use this equation because this is going to mess us up, right, when we do the calculations. So we do have to use the Pocomo equations, and we do have to use the RSA RSS equation, right, which is this one here, which is the u1 minus u2 equals to v2 minus v1, right? That was the equation. I adapted it for this one. So there's actually two equations, bro. Now, I mean, since I'm on this, right, I might as well just say it out because, like, you know, in case you all, I really hope you all don't make a mistake in the upcoming test or anything like that. I'm just gonna say it out, okay? If you go and review that video, I did mention that this is number 1 and this is number 2, right? Okay, remember this, if you don't remember anything else, just remember this. Please remember to always sub the Pocomo equation into the RSA RSS equation, not the other way around. Okay? Not the other way around. There's a reason behind this. I think I mentioned it briefly in the video of during the March holidays, but I emphasize again, please do not sub it the other way around. Sub Pocomo into RSA RSS. In fact, I'm gonna do that now. How about that? So I make Vy the subject. Vy is equals to V minus Vx. Okay? And then I sub 1 into 2. So this is number 1. I sub it into 2. So V equals to V minus Vx minus Vx. So then you realize 0 equals to minus 2Vx. Correct? Then that means Vx is 0. Okay? So this is me showing you, right, that ultimately Vx is 0 and therefore Vy is just V. Yeah. Okay? So this one correct, A is your answer. Right? Dynamics collision is one of the most fun topics to get right, because you definitely will be able to do things that the other students won't be able to do. But you have to, I'm sorry to say, but you have to follow my instructions, because I've already kind of like streamlined it into a process where if you follow those instructions, you will always get it right. Okay, so if you have to review this, the processes, please go ahead and review it. Okay, last question for tonight, right? Otherwise, Eric's parents gonna kill me for holding him hostage here. What? Okay. Okay. Right. I'm just gonna draw my own copy of it, cause you know I kind of want to. Right. So I'm gonna draw this one. So I got a small mass. I got a big mass. Right. I got this force here. Right. Okay. Right. And there's no friction, so smooth floor. Right. Smooth floor. What is the force that big M is exerting on small m? What do they want? Like, I mean, what do they want? How does it look like? Yeah. Right. How does a big mass look like it's exerting on a small mass, right? They want this arrow here. Right? So this is like the question, right? You know, the question here like this. Okay. Right. So do we recognize that finding this force is the same as finding this force? Right? So it's kind of like the same question prime. Okay? Right, question prime. Then remember, you know, in the more recent videos, no, actually this is also in the this was also covered inside the March holidays. Yeah, the March holidays videos, right? The Newton's 3 laws, right? Newton's first law, second law, third law. Right? Okay. Learn how to do the big picture, small picture thing. Am I right? I think in the video I said big picture, small picture. Let's look at the big picture. This force, right? If I combine the two masses, this force causes these two masses to accelerate, right? So can I write that F equals to M plus big M A? Correct, huh? Okay. Right, so that's the big picture. Big picture, I'm looking at the whole thing. Right? Right? This force causes them to accelerate. So now what I want to do is I want to look at this mass here, right? Let's isolate this guy. Right? We isolate this guy here. Right? Isolate this guy here. Box him out. Right? So this mass here. Right? He experiences that force. Okay? Right? This question mark prime. He doesn't experience force, this big F directly. He experiences a force from the small mass that causes him to accelerate. Okay? There's no friction. So that means that this unknown force is the resultant force for this big mass. And therefore, what I need to do is I need to sub in A. I need A. 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 There's something wrong? Wait, is this not an answer? Oh shit, yeah, oh my god. I was looking for options that has F in it. I thought they wanted me to put F inside here. No, that's it. That's it. That's it. That's it. Like that's the answer. Like the force that they want me to find that the big M is exerting on small m, which happens to be the same force that the small m is exerting on the big M, and we establish that this force will cause big M to accelerate, and therefore this unknown force is MA. This is the answer over there, right? That's the answer. Oh, wait. I understand why. Because it's very unnerving. It's very strange. How come the force that's acting on a small mass, how come it's big MA? Like, I don't get it. Like, you know, like, why is it big MA? But it's not. There's no, how do I say, underlying principle to it. It's not like, oh, every time the small mass is always going to be big MA. No. There's no such principle to that. This is me working out big picture, small picture, figuring out what's this force here, and then realize, oh, yeah, it just happens to be the answer lah. Don't need. Yeah, you don't even need to. I mean, I didn't realize. I thought the option had like F in it. I didn't realize. I thought, yeah, that's why I was like, at some point I was like, okay, I need to sub the A in, then I bring this into here, then I look for an option, then I realize, eh, shit, the F is not inside. Yeah. Huh? But this style? This is the, you know how you wake up in the morning, you brush your teeth, then you wear your clothes, then you go to school, you take a bus, you go to school, right? Yeah, this is that style. This is the what do you want to do again? This thing again? Alright, this thing again, then I do this thing again, so I just do the same thing again and again, and then I got tricked lah halfway. I was like wondering, right? I don't need, yeah. Oh, it was school holiday, I didn't have to go to school. like you know, then I realized, oh, it's school holiday, right? Like, but I woke up to brush my teeth lah, so you know, yeah. Okay. Yes. So the questions here kind of feel like it's coming from the March holiday videos, right? Like during that period of time, right? Including all the questions before this, a bit of the collisions and all that. So go and review those videos again if you have to. But please, I mean, congrats, and I really appreciate this for doing the practice. Okay, that's like super important, right? But hopefully once you review the videos, right, you will understand the next time you do a question like this, right? You understand like what's the underlying reason why it's done this way. Okay, then if you know, I mean, these are all the questions given from the teacher. These are all past year questions. If you see the shared drive here that I've posted, you can see the topical past year IB. You can go ahead and use this as well, right? So the A2 here, and you can do all these questions as well. It's like a lot of it is MCQ. Is the test only MCQ, Portia, Jovin? Yeah, the structure, right? So go ahead and then you can get some structured ones from there as well. Right? These are literally past IB questions. Like if you see the thing here, this is May 24, last year May paper. Right? Yeah, you can go and see what are the other different kind of questions there. I mean, if your teacher come out with those as practice, I don't think they're going to set those questions, right? Then you better look at others. Yeah. Okay. Any further questions? Ooh, look at this one. Yeah. Any more? All right. Otherwise, I think I'm actually also a bit spent already, lah. So anything else, you just drop me a message. Okay. Thank you, Portia. Thank you, Jovin.